Okay, question 14. A curve C has parametric equation x equal to 3 plus 2 sine t and y equal to 4 plus 2 cos 2t, and t is more than equal to 0, less than 2 pi. Part A wants us to show that all points on C satisfy y equal to 6 minus x minus 3 squared. Okay, so it basically just parametric equation change into the Cartesian equation. Yeah. So let's do part A quickly. So I will just use the identity cos 2t equal to 1 minus 2 sine square t. I think this is the easiest identity can link both two. Yeah. And then cos 2t is just same as y minus 4 over 2. If we make cos 2t as a subject, just minus 4 for both sides and divide by 2 for both sides. And then for sine t, that will just be x minus 3 and then divide by 2. And since the sine square t, we just square that. So simplify this, we have y minus 4 equal to 2 minus 4 times by. If we square that, it will be x minus 3 squared over 4. So this 4 over 4 cancels out. So then y minus 4 equal to 2 minus x minus 3 squared. So plus 4 for both sides. We have 6 minus x minus 3 squared, which is the same as part A. Yeah. So part A is done. Quite simple. And then part B, sketch the curve C. So this is just a quadratic, and then is, if we rewrite it, is negative x minus 3 squared plus 6. So it's a negative quadratic. It has to look something like this. And the turning point is 3, 6. So if we sketch this one out, it will be something like, so because the turning point is 3, 6, and it's a negative quadratic. So I'll put 3 somewhere here, 6 somewhere here. And then the y-intercept is 1x equal to 0. So 6 minus negative 3 squared. So 6 minus 9 is negative 3. So the y-intercept is something here. So it'll look roughly like this. Yeah. But always be careful. This is a parametric equation. Yeah. It's all about domain and range. So it says t is more than or equal to 0 and less than 2 pi. So that would be the possible t values. So we need to use that to find the possible x and y values to find the domain and the range. So if t is between 0 and 2 pi, that's just a one full period for sine and cos. So that means sine t has to be between negative 1 and 1. So that means 2 sine t has to be more than or equal to negative 2 and less than or equal to 2. And if we plus 3, so 3 plus 2 sine t has to be equal to, more than or equal to negative 2 plus 3 is 1, and then 2 plus 3 is 5. So x has to be more than or equal to 1, less than or equal to 5. And then for the possible y value, so because t is between 0 to 2 pi, so that would be one full period for the sine and cos. So cos 2t, it should also in between like negative 1 and 1. So 2 cos 2t will in between negative 2 and 2. So 4 plus 2 cos 2t. So if we're plus 4, then negative 2 plus 4 is 2, and then 2 plus 4 is 6. So that means y has to be more than or equal to 2, less than or equal to 6. So the only value for x has to be between 1 and 5. So no other parts, just 1 and 5. And then it has to be look something like this. So that's the only possible value for x, just between 1 and 5. And then y is between 2 and 6. So that's why the lowest point has to be 2. So for those two lowest point, the y value has to be 2. Yeah. So this will be the actual curve, not the whole thing. Yeah. And then explain briefly why C does not include all points of y equal to 6 minus x minus 3 squared, where x is all the real value. It's just because x can only in between 1 and 5, or you can say y can only in between 2 and 6. Both works. Yeah. And then part C, the line with equation x plus y equal to k, where k is a constant, intersects C at two distinct points. Yeah. So if it's about the number of intersection points, it's all about the discriminant. So we need to use the discriminant to solve that. So I will write the equation first. So y equal to 6 minus x minus 3 square. And then for the other one, I will make y as a subject. So y equal to negative x plus k. And then set up the equation, negative x plus k is equal to 6 minus x minus 3 square. So then negative x plus k equal to, expand the brackets, that will be x squared minus 6x plus 9. Then negative x plus k equal to 6 minus x squared plus 6x minus 9. Move everything to one side, so plus x squared for both sides, and then minus 6x for both sides. So negative x minus 6x is negative 7x. And then k is just k. So 6 minus 9 is negative 3, and then plus 3 for both sides. That's the quadratic equation. And then because it's two distinct points, so that means discriminant b squared minus 4ac has to be more than 0. So b is negative 7, and then minus 4ac is more than 0. So 49 minus, so 4 times k is just minus 4k, and minus 4 times 3 is minus 12, more than 0. So 49 minus 12 is 37, and then plus 4k for both sides. So 37 is more than 4k. So k has to be less than 37 over 4. And it's not done yet. Yeah, this is a parametric equation. It's all about the domain and range. So 37, k is less than 37 over 4. So x plus y equal to k, so that means y equal to negative x plus k. So it's a negative straight line. So the gradient is negative, it has to be decreasing. So it has to be look something like this. Yeah. So for a normal full quadratic graph, that's fine, because like this is one section points, and then if we try to move this down, so you can see that would be two intersection points, two intersection points, two intersection points. It's always two intersection points. Yeah, let me make it a bit longer so you can see it's always two intersection points, because like this is infinite long. So it doesn't matter how low you're gonna move, it always intersects at 2 points. But this is not a full quadratic. The blue one is not the curve we sketched. The red one is. So that means if you move this straight line down a little bit more, so let me keep the black one here and then paste another one. So like if we move this line down, so this is two intersection points, still two intersection points, and then this is two intersection points. But if we move this line a bit lower, that will be only one section point. So that's why it has a lower bound. 37 over 4 is the upper bound. So we need to work out the lower bound. So that lower bound has to be when this line cross the lowest point. That will give us the lower bound, because a bit lower than that will be only one section point. So this is still two intersection points. So we just have to work out what the k value for this one, which is right easy to find because we know what this coordinate is. So that coordinate is when x equal to 5, y equal to 2. And in the straight line is x plus y equal to k. So substitute in 5 plus 2 equal to k. K is equal to 7. So when k equal to 7, that will be the lower bound. And then therefore k has to be more than equal to 7, because at that instant still two intersection points. And then less than 37 over 4, because this is the tangent, only one section point. So it has to be anything between those two lines. So more than equal to 7 and less than equal to 37 over 4. So just be careful, like for parametric equation question, it's all about the domain and range. And they want us to write in the set notation. So I will say, okay, k and then straight line, and then k more than equal to 7, less than 37 over 4. That would be the final answer. Or some people use like double dot. I think both works, but I normally just draw a straight line here.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.